So page 19, surface area of composite figures. So yesterday we talked about composite figures. Now we're doing composite figures of 3D shapes. Okay. There was a question in the homework that already deals with this, but I'll just do a more formal lesson on this. What shapes do you see here? What shapes do you see? Grace, you were really good with shapes yesterday. What shapes do you see here?
A rectangle.
Okay, but it's a 3D shapes. So what's the 3D version of a rectangle?
Oh, a rectangular prism.
Rectangle prism, right? Rectangular prism. And what about this top part? What is this one called?
Triangular.
Triangular prism, right? Okay, so we know we want to find the surface area of those. So I could, one, break it into the parts, or I can draw the net. Either way, as long as you find surface area, it's good with me. So let's say right here. Okay, so for this question, I think it's actually easier if you just break it into parts and open it up as a net. The only thing I actually don't know is this is my only tricky shape. Okay, so this rectangle on the bottom right here, I know it's a 8 by 4 rectangle. So 8 times 4 is just 32. So I know the area of that part is just 32 centimeters square. What about this part? How do I calculate the area of this triangle right here? First off, what's the formula for area of a triangle? Yep. Perfect. Base times height divided by 2. So what's my base of this triangle? Just looking at that triangle? Kaden?
8.
And the height of this triangle? Yes. Where did you get 6 from? Not the... Oh, right. Okay. So this part is 4. The whole thing is 10. So when you subtract it, that means this part only is 6. Right? The whole length is 4. You always compare it with the parallel parts. So when you subtract that bottom part of it, it's just 6. So 8 times 6 divided by 2 is 24. What's my unit? Ethan? Right. Let me just... Okay, resuming the video. So now that I have this is 24, this is 32. So the area of this front part right here, the area of this shape, is 24 plus 32, which is 56. Okay, how many of these sides do I have in this figure? 2 of them, right? So don't forget, you have to times it by 2. So 112. Right, so I got the front face, I got the back, and then now I just have to add up the other 4 rectangles. So the big rectangle on the top, okay, length times width, since it's just a rectangle. What's the dimension of this top rectangle? Right here, this one. What are the dimensions of this one? Oh, not as easy. Okay, Melody. Where did you get 10 from? Oh. Okay, so I'm trying to look for, here, I'll highlight it. I am trying to find the area of this rectangle right here. Okay, so this one right here. Okay, I know that this is 3, but do I know this? Do I know the diagonal? No. So what should we do if we don't know a length? Yeah.
Oh, you're using Pythagorean theorem.
Pythagorean theorem, right? Pythagorean theorem. Whenever you don't know a length, it's always Pythagorean theorem. Okay. We're looking for this diagonal, and so let me erase this so that you don't get confused. Here, I'll erase. Okay, so c squared equals a squared plus b squared. So c equals the square root of, this is 6 right here, so 6 squared. And this length, this dotted line right here, is 8, so 8 squared. So c equals 6 times 6 plus 8 times 8. We get 100. 100 square root that, we get 10. Okay, so so for this rectangle, I know it's a 10 by 3 rectangle, which is 30. Okay. How many of these do I have? Just the one, right? Right. Now this part, this black square, I'll try to do different shapes, different colors, so that you can see which is which. So the black one right here, area equals length times width, so it's just simply 3 times 4, which gives us 12. Okay, what about the base? The base, the bottom. The bottom, what shape is on the bottom? Yeah, Melissa? Rectangle, right? And it's just an 8 by 3 rectangle. So for the bottom, 8 by 3, so 24. And then lastly, the side right here. The side, the rectangle on the side, it's 10 by 3, which is 30. Okay, how many surfaces does this shape have in total? Yep, six faces, right? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I should just be adding up the 6 sides. So 112 plus 30 plus 12 plus 24 plus 30. I get a total of 208. What's my unit? Unit? Yep. Centimeter. It's area. Square. So if it's area, it's square. Good. Okay. Here's a advanced question. Okay. What if I wanted to ask the volume of this shape? Okay. It's actually at one step. I can just do this in one step and get my volume of the shape. What do I do? Think. I just need one step to figure out the volume of this. How do I figure out the volume? Hey, who's my big brain here? Ethan, do you know? You want to take a guess? Okay, let's hear your idea. I always like ideas.
Like two of these shapes, you could create like a long rectangle thing.
Okay. I think I like your idea. I get what you're going with, but not the rectangle. Right, who knows what to do? Okay, so do I know the area of this front side right here? Do I know the area of that front side? What is it? 56, right? So for volume, if I know this, my face, I just have to times it by the length of it, and that will give me my volume. So 56 times the length of this shape, which is 3, and that's my volume. 56 times 3, 168 centimeter cube. All right. This goes for any shape. It could be a shape like this. It could be a star. It could be just like in the cylinder. Okay, so you know how a cylinder, you find the area of the circle and then you just times it by the height of the cylinder? Same idea. So as long as I know the area of the face and I times it by the length, I will get volume. Okay. Sorry? Yeah. Yeah. So in other words, you can also think about it, what shape is keep on repeating. So is this right here. That keeps repeating for 3 centimeters long. Okay. Example 2, let's just scrap it because it's an extension question. It's nice. I like it, but it's time consuming. So instead of losing you guys after a fire drill, we'll just skip that one. All right. But basically, if you do have time after and you want to try this question, by all means. So what this question is like you have frosting and you have to put it on top of these 2 cakes. So do you count the surface of this cylinder right here? No, you only have the top cylinder. And then you don't count the bottom of this as well because you don't put frosting on the bottom. Okay? So that's the idea of that question. Okay, example 3, finding the surface area given the volume. So suppose you have a Campbell's soup can that has a volume of 500 centimeter cube and a radius of 4 centimeter. How much aluminum is used to make this can? Okay, so yesterday we talked about this, how to convert a 3D shape into a word problem. So when I ask how much aluminum, what am I asking? Yep, surface area. So basically, I want to find the surface area. It's a can of soup. What shape are we talking about? A can of soup.
Cylinder.
Cylinder, that's right. Okay, so this one, what's interesting with this one is I am dealing with volume and surface area of the cylinder. So volume of a cylinder, who knows the formula? Yep, Ethan?
R squared H.
Right, R squared H. Was your hand up or were you just rubbing your nose? Oh, sorry. I thought your hand was up. Okay. So, but normally we would just plug in these numbers and then we get our volume. But this time I tell you what the volume is. So I'm actually going to replace the V with 500. I know pi is 3.14 and I know the radius is 4 square. So what do I not know? I don't know what H is. All right. But luckily, that's the only thing we don't know. So that means we can do algebra to solve for it. So 500 equal 3.14 times 4 times 4. I get 50.24 H. So how do I solve for H? We did this for like the last 2 months. Catherine? Drag it. Get over here, 50. Divide, right. See, divide sounds so much more polite than dragging it over. Okay, so divide. So 500 divided by 50.24, you get 9.95 equals H. Okay. By the way, what's my unit here? I don't need it yet because it's not part of my final answer. What's my unit? Cheyenne?
I think it's centimeters.
It's just centimeters because it's the height. Good. Okay. Was that what it was asking me to do? Was that the question though? No, right. You were asked for the surface area. Surface area of this cylinder. Who has the formula? Yes. Refer to the good. I hear the flipping. That's good. You know where to go to find the formula sheet. What's the formula for surface area of a cylinder? Martin.
2 pi r bracket r plus h.
Okay. Or on that sheet, it will be 2 pi r squared plus 2 pi r h. Okay. So now we have everything. 2 times 3.14 times radius, which is 4. And then plus 2 times 3.14 times 4 times your height, which we just found to be 9.95. All right. Put this all in the calculator. That's why I don't think this test is hard, because you're given the formula, you're given a calculator, you're just telling the calculator what to do the hard work for you. Okay, so 2 times 3.14 times 4 times 9.95. Okay, and I get my answer 350. Let's say round to 1 decimal place. This will be 350 point what? 4. Right? Because you look at the next one, it's a 2, so you round down, so it's 0.4. My unit, Adrina, what is my unit for surface area? Area. Just like what you told me up here. Centimeter square. Will you remember that for the test?
Yeah.
Yes. What happens if you put cube?
It gets counted as
Wrong. How much mark am I taking off?
all of it.
0.5.
1.
Yeah. Wrong unit? 0.5. Am I that mean to you? Yeah, I didn't want to. You don't have to answer that.
Yeah, that's on YouTube.
I know, eh?
I can answer that, obviously.
No, it's okay. I know you guys love me. No, editing is too long. Editing takes too long. You can see that I don't even do a picture.
Intro.
Yeah, I know.
You get more views on.
Yeah. Okay, last thing, I just want to go over really quickly. This doesn't take long. It's just page 21, comparing figures. This takes very little time. Okay, which of the following cones has the greatest volume? Show this mathematically. So, take a look at these three. A cone that is equal, cone A. Contestant number 1, cone A. Height is equal to the diameter. Okay, so the height is the same as the diameter, so this and this is the same. Or cone B, the height is double the height of cone A. Okay, so if this is h, this is 2h. Alright, and the diameter is the same. And then cone C, okay, the height is half of cone A, but the diameter is twice as long. Right? So just a hypothesis. Let's do a vote, and then we'll see who's right, who's wrong, who didn't guess at all. Okay, so I'm not marking you guys on this. I'm just participation. Okay, it's okay if you're wrong. We're guessing, and then we'll prove it. Who says cone A will have the greatest volume? Who says cone B will have the greatest volume? Alright, who says cone C will have the greatest volume? Okay, so you guys all think that fat one will have the greatest volume. Fat cone. Okay. No, it's a joke. See? Cone 1 with the C. I know, I'm thinking I really need to edit this video now. Okay. Yes, please. Okay. No, because look, I said no. Calm, calm, one. That's you. Fine. You don't get it. Fine. Yeah, one. Back home. Okay, never mind. Okay, so for A, volume of the what's the formula for volume of a cone? Good. Flip those pages. I want you guys to get used to looking. Not a half. 1/3. Right. So pi r square h divided by 3. A third. Okay. So for this one, height is equal to the diameter. So if I call this r, okay, what would the height be then? If the radius is r, Eliana? 2r, right? Because your diameter would be 2r, which means your height is also 2r. So let's sub in those numbers. So pi, I'll leave it as pi for this time. Okay, radius, and then the height is 2r. Okay, when I simplify this, that means this is 2 pi r cubed divided by 3. Okay, this one, height is doubled and the diameter is the same. So if this is r, what is this height now then? What is the height of that cone? Cheyenne? Huh? What is the height of this cone?
Wait, if that was 2, that would be like 4.
Right, that's right. So this would be 4r. So for B, it's going to be pi times r squared times 4r divided by 3. Okay, so then already I see that B definitely is bigger already. B is in fact double. Okay, and then C, this one that you guys said, height is equal to that of cone A. So height is equal to that. So this is 2r. But the diameter is twice. So what is this right here? 2r. Okay, so volume of C is pi times your radius is 2r and your height is 2r. Okay, so if we simplify this, that means this is 2 times 2 times 2, 8. 8r, whoops, 8 pi r cubed over 3. Okay, so yes, you guys are correct. It's C. All right, C. In fact, B is doubled the volume of A, and C is double the volume of B. Okay, and if you have to like do all this math to show it seems like so much work, you can actually tell from the formula itself, because whenever you square something, it's always bigger than when you time something. All right, so the effect that it has on the radius is bigger than the effect it has on height. Okay. Number 2, draw 3 rectangles with a diameter of 40. Which one has the greatest perimeter? Okay, so let's say I have this rectangle right here. Perimeter is 40. Can somebody give me one possibility? One possible length and width of this rectangle. Eliana? 4 and 10. 4 and 10 gives me area. I want perimeter. Elena? 15 and 5. Good. Okay, so this could be 15, 5, 15, 5. Yep, that adds up to 40. Another one. All right, another one. Ethan?
Wait. 10 and 10 and 10.
10 and 10. That's right. Okay, I could have a 10 and a 10 and a 10 and a 10. All right, what's another one? Give me one more. Eliana? Yes, it is. It's a square rectangle. Is a rectangle a square though? No, yeah. So square is a rectangle, but a rectangle is not a square. Yeah. Is tomato a fruit or a vegetable? Right? So give me one more. One more dimension. Let's see. Misha, can you give me a random one?
20.
Yeah, the 20 won't work. 19 would. And this would be? 1, right. Okay, so 19 plus 19 plus 1 plus 1 gives you the 40. Okay. Which one of these has the biggest area? Oh, oops. The question is wrong here. Oops. Has the greatest area, not perimeter, area. Yeah, if you can change that question. Because I told you the perimeter is 40. Which one has the greatest perimeter? All of them have a perimeter of 40. Greatest area. Which one is it? The square. Yes. And if you try like 10 different shapes, 100 different shapes, maximum area, minimum perimeter is always a square. Maximum area, minimum perimeter is always a square. Okay. I will ask this on the test. Right, what shape gives the maximum area, minimum perimeter? Square. Not triangle, not cube, not sorry, not not oval. Okay. Square, 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 square. What's the 3D shape of a square? Yep. Cube, right. So same idea applies with maximum surface area, minimum minimum no, maximum volume, minimum area. Yeah. Okay. One last thing I want to talk about. What is the volume of the space not occupied by the cone inside the cylinder shown if both shapes have a height of 10 centimeters and a radius of 5 centimeters? Okay. So cone, cylinder, these are the numbers for it. So the radius is 5, height is 10, which is the same for the cone and for the cylinder. So if I want to find the space not occupied by it, I'm going to find am I talking about volume or surface area then? If I'm talking about the space, the inside space, volume, right? So volume of a cylinder, okay, pi r square h, 3.14 times radius, which is 5, times the height, which is 10. I get 3.14 times 25 times 10, 785. The volume of the cone. What's the formula for volume of a cone? We just talked about it. Pi r square h divided by 3. Okay, so let's say I'm very lazy. I don't want to plug in all those numbers again. What do I have to do? All I have to do is, yep, divided by 3. Right, see, pi r squared h, pi r squared h. Yeah. So 785 divided by 3. And I get 261.6666. Okay, so when I subtract them, subtract the two volume, I get the volume. So the volume of the space that's not occupied by the shapes, 523.3 centimeter cube. Okay. So what is the connection between a cone and a cylinder? Taking a look at the formula, what's the connection between them? All right, so let's say I'm pouring, you know those triangle cups, paper cups that you pour water in at those like doctor's office? Okay, if I have that and my mug, which is like exact same size, I don't know why, but let's say it is, how many of those paper cups can I use to fill up my mug? 3, that's right. So the connection between them is 3 times. This question always comes up on EQAO. So they would ask, for example, how many cones make up this cylinder? So it's 3. They could also ask, if I have this mug and I pour it into that paper cup, how much water did I use up here? So if I use this, I pour it in here, how much would I use up? A third, right? Okay. The other question that I saw before is how much water is left in the cylinder? 2/3, right? Okay, so you have to know like the wording. They like to play with wordings. So you know that the connection between them is 3. So depending on the wording, your answer could be 3, a third, or 2/3. Okay. And this goes for not just the cylinder. It also goes for uh, pyramids. Okay, pyramid and prism also have the same relation. Okay, so it's by 3. Then what do you think about the rectangular prism and a triangular prism? What's the connection with these two then? What's the connection with these two? This one is length times width times height. This one is base times length times height divided by 2. Ethan? Okay, Martin? Martin?
Wait, for like the cylinder question, can you just do 2/3, like pi r squared h?
Okay, 1 second. Let's finish up this question first. Can you answer my question first? What's the connection between volume of a rectangular prism and volume of a triangular prism?
For triangular prism, we divide by 2.
Divide by 2, right? So the connection between them is 2. Connection between these two is 3. Connection between the cylinder and the cone is 3. Okay. Does the same apply to surface area? Take a look at the formulas. Does the same relation apply to surface area? No. Okay, only for volume. The connection is only for volume. Okay, and then Martin, your question, you were asking about the 2/3 and this?
Yeah, can you just do 2/3 pi r squared h for the next question?
Uh, two. Let's see. Let's see if we could. 2/3 2/3 pi r square h. You could, yeah. So it does work. Okay? Because just like the same logic, this is a third of the cylinder, so that means 2/3 of the cylinder is left in this cone, in this cylinder. Yeah, good observation. Okay, so your homework for tonight, this weekend, I am doing homework check on Monday. Okay, page 20 to 22, 23. 20, 22, 23. Okay, answers are on page 24, so you can check. 20, 22, 23.